So quarks and the arrangement of particles. So after the advent of particle accelerators, and because physicists didn't see that there was an apparent relationship between all of the particles created, they described the random array of particles as a particle zoo. And it wasn't until the 50s and the 60s when two physicists independently proposed the existence of subatomic particles. One was Murray Gell-Mann, and the other one was a guy called Zweig. And what they suggested is that there are more fundamental particles than the proton and neutron that make up matter. To date, we believe that there are 6 quarks and 6 corresponding antiquarks to go with the arrangement of leptons and charge carriers. So let's have a look at the syllabus then. So we're on number 8 there. We're looking at quarks as the building blocks of baryons and mesons. There being 6 quarks, up, down, top, bottom, charm, strange. Their charges are plus 2/3 or minus 1/3. Antiquarks have the opposite charge to quarks but the same mass. We also need to come across or deal with 2 types of baryons, the proton and the neutron, as well as other baryons. We need to have a look at mesons, which are made up of a quark and an antiquark. And then in the third column over, you need to identify the nature and charge of a particle giving a combination of quarks. Now in the final column there, you can see there's a quote from James Joyce. That's from James Joyce's Finnegan's Wake. It says 3 quarks for muster mark. And the name Quark was taken from James Joyce's play Finnegan's Wake. And that quote you will need to know. So let's have a look at the quarks first of all. This is page 49 of the log tables. The right hand column we've up, strange, top, down, charm and bottom. Their charges to the left of that, they're either 2/3 or minus 1/3, and to the left of that are their symbols. So U for up, S for strange, T for top, and so on and so forth. And they're normally grouped into pairs. So up and down was the first generation of quarks discovered because those are the largest. Then you have charm and strange, and then top and bottom. So there are 3 generations, up, down, strange and charm, and top and bottom. Okay, so how does that fit in with the standard model? So with the standard model, we can see that we've got 6 quarks. Those are the particles that make up hadrons, so they make up mesons and baryons. Below those 6 leptons, which are considered fundamental particles. Then we have charge carriers and the mass creator or the mass carrier there, the Higgs boson. Okay, so quick recap there of those. And moving on. Also, we've done the following. The leptons don't feel the strong force. They feel the other forces. And if they're charged, they feel the electromagnetic. If they're not charged, they don't. The hadrons, which are composed of quarks, will feel all of the 4 forces if they're charged. If they're not charged, then obviously they won't feel the electromagnetic force. Quick recap. Okay, so the particle groupings. We have 3 groupings there, leptons, mesons, and baryons. Leptons, fundamental particles. Mesons are made up of a quark and an antiquark. Baryons are made up of either 3 quarks or 3 antiquarks. So let's look at the part we're looking at or we're interested in. We're interested in the mesons and we're interested in the baryons. So you need to know 1 quark and 1 antiquark for the mesons and either 3 quarks or 3 antiquarks for the baryons. And in the second column there, you're given a list of different mesons and different baryons. So the first 3 are the pi mesons. There's a pi positive, a pi negative, and a pi neutral, so 3 different charges depending on their quark composition. There's 3 kaons, positive, negative, and neutral, depending on their quark composition. And then if we look at the baryons, you have the proton and the neutron, which you need to know their quark composition. You've then got the lambda. You've 3 varieties of sigma, 2 varieties of psi, and 1 omega that are in the log tables. And the charges are associated with those as well. Remember that in all nuclear reactions, the charge needs to be conserved. So that will determine what will go down in a nuclear reaction if you're asked it in the leaving cert. All right, antiquarks. It's very straightforward. Antiquarks have the same mass as quarks, but they have the opposite charge. So on page 49, these are the quarks. If you were to give the symbol for the antiquark or give the charge for the antiquark, they would look like that. So the charges change and you put a bar over each of those symbols to denote that they are antiparticles. Okay, will you go to page 373 now of the textbook, and I'd like to know which of those particles are mesons and baryons. There should be 10 short questions, question 1 in 10 parts on that page. Pause the video, I'm going to keep going. Alright, if we look at the proton is made of up, and a down quark. Now to calculate the charge, what you do is you add the charge of the up quark to the charge of the next up quark to the charge of the down quark. So the up quark has a charge of 2/3, so we'll have 2/3 plus 2/3 is 4/3, and the down is a charge of minus 1/3, so you have 4/3 minus 1/3 gives you a charge of +1. And that's how we get the charge on the proton. If you repeat that then for the neutron, if a neutron is up, down, down, get the charge of 1 up and 2 downs. So 2/3 minus 1/3 minus 1/3 gives you a net charge of 0. You can do that for any particle. So let's have a look at what happens when we have an antiproton and an antineutron. Well, if we start with the antiproton, the quark composition will be the anti-up quark, the anti-up quark, and the anti-down quark. Remember, anti-up has a charge of minus 2/3, so we have minus 2/3 minus 2/3 is minus 4/3, and the anti-down is a charge of plus 1/3. That gives us a net charge of 1. So the antiproton has the same mass as the proton, but it's got the opposite charge, and that's down to the fact that it's got the anti-quark composition of the proton. And you can repeat that for the neutron as well, but you'll notice the charge on the neutron and the anti-neutron is the same, but the quark composition is different. Okay, if you go to that page again, 373, you've got the 10 quark compositions. Will you work out the charge on each of those? Pause the video, but I'm going to keep going. All right, what have we covered? We've already covered leptons, baryons, and mesons from row 6. And we've covered everything there in 8. So the quarks, the 6 quarks, their charges, antiquarks, the composition of the proton and the neutron. I've also identified other mesons and other baryons. We've identified the nature and charge given a quark composition, and I've talked about 3 quarks from us to mark. And that's it.